So the next part of algebra and polynomials is to do with our skills with completing the square, factorizing. So this is just revision from GCSE. So hopefully you've been taught all this. So what I'm going to do is I'm going to do one of them, then you do the rest. So watch these 4 examples of how to complete the square, and then try the 4 next to it yourself. So x squared plus 10x minus 3. Well, to complete the square, what I do is I half the value of b, so I get 5, and I put that in a square bracket. And that's because when you think about the binomial, if I expand it to something like x plus y squared, the binomial expansion tells me I get x squared plus 2xy plus y squared. So I get 2y times x. Here's 2y. So if I want to get what number will go in the bracket, I have to half the number in front of the x. So it's a 10 there, so I half it and get 5. The next thing I need to do is I will get a y squared at the end, so I want rid of that. I need to take away 5 squared. So now that just gives me x squared plus 10x, and I need to minus the 3 that's already there. So then just simplify that to x plus 5 squared minus, well, 25, take away 3 is minus 28. And that's it. That's how you complete the square. So next one. So same thing. I have my brackets, and I half the number in front of t. So t plus 5 over 2 squared. Try and use fractions, not decimals. Take away that number squared. So take away 5 over 2 squared plus that 1 that's already there. So I get t plus 5 over 2 squared. Take away, well, 5 squared is 25, 2 squared is 4, plus 1, well, I can write 1 as 4 over 4. I can just simplify that to t plus 5 over 2 squared minus 25 plus 4 is minus 21 over 4. Now, on this next one, if we have a number in front of the squared term, our trick is we're going to factorize out that number, but just from the first 2 terms. If I do it for all of them, and so if I do it for the 5, I will get fractions. I want to try and avoid fractions. So I'm going to factorize out the 2. So I'm left with m squared plus 4m, and then a plus 5 at the end. Now what I'm going to do is I'm going to complete the square on this bit in the brackets. So to complete that square, I will do m add 2 squared minus 2 squared. So I get m add 2 squared minus 4. So that gives me the blue bit. Then I'm going to multiply it by 2 and add 5 at the end. So I get 2 lots of m add 2 squared. Take away 2 times 4 is 8, plus that 5, and just simplify that to 2 lots of m plus 2 squared minus 3. Minus 8 plus 5 is minus 3. And then the last one, if there's a negative, so I've got negative a squared, then what I can do is I can do the same thing. I can, if I get my hider, I can factorize out a minus 1 from that bit. So I get 8 minus a squared plus 6a. Because I've factorized out a minus, so that minus 6a turns to plus 6a. I'm going to complete the square in just this bit. So 8 minus, I get a plus 3 squared minus 3 squared So I get 8 minus a plus 3 squared minus 9. And now I'm just going to times by the minus. So 8 minus a plus 3 squared minus 9 makes plus 9. So I get 17 minus a plus 3 squared. So can you have a go at the 4 next to them? So using the same idea, so you might want to rewind the video, try them again, and then I'll give you the answers either at the end of the video or I'll send them separately. Okay, so now we know how to complete the square, we can look at some of its applications. So the first one, and I'll let you just read those bullet points yourself. So the first one is we can prove the quadratic formula. So I'm not going to do all the steps for you, I'm just going to get you started and give you some tips. So the first thing we do for this is, since it's an equation, then I can divide by a. So if I divide everything both sides by a, I get x squared plus b over a x plus c over a equals 0. Now if I complete the square on that, I'll get x plus, if I half b over a, I get b over 2a squared, and I need to minus b over 2a squared, and plus c over a equals 0. So I get x plus b over 2a squared, take away b squared over 4a squared, plus, now this bit here, it's c over a, but if I want 4a squared on the bottom as well, so I've got a common denominator, I need to times the bottom by 4a, so I need to times the top by 4a, so I get 4ac. So hopefully it's starting to look a bit like the quadratic formula. If I take it to the side, I get x plus b over 2a squared equals, sorry, I just equals 0 there. I get b squared minus 4ac. They're both over 4a squared, so I'm just going to put 4a squared on the bottom there. Then when you square root, you get the root bit, you'll get this bit. Not all of it, not the minus a at the front, but I get the plus or minus root b squared minus 4ac. And when I square root at the bottom, 4 square roots to 2, and a squared square root to 2a. And the last step would be to minus the b over 2a. We can prove that some expressions are always positive, always negative. So I've got x squared plus 6x plus 10, and I want to prove that's always positive for any real value of x. So completing the square will help for this as well. So if I complete the square, so x plus 3 squared minus 3 squared plus 10. So simplify, I get x plus 3. 3 squared is 9, so I get minus 9 plus 10 is plus 1. Now the trick here is x plus 3 squared, that's a square number, so that's never negative, it's always bigger than or equal to 0. So therefore this expression here is always bigger than or equal to 0 plus 1. So x plus 3 squared plus 1 is always bigger than or equal to 1. And you might remember from GCSE, when you complete the square, it helps you work out the minimum. So we would say the minimum is 1. So therefore, if it's bigger than 1, it's bigger than or equal to 1, sorry, then it's always bigger than 0. So therefore, it's always positive. Yeah, done. Okay, can you try the one below yourself? So press pause and try and prove that that expression is always negative. Okay, so hopefully you've had it coded yourself now. So I would factorize out negative. So I get negative x squared minus 4x minus 5. And I'm going to complete the square on this bit. So x minus 2 squared, take away 2 squared. Put a minus at the front and a minus 5 at the end. So I get minus x minus 2 squared. The minus and minus makes a plus, and 2 squared is 4, so I get plus 4 minus 5. So I get minus x minus 2 squared minus 1. And from the same idea before, x minus 2 squared is a square number, so it's always bigger than or equal to 0. So minus x minus 2 squared is always less than or equal to 0 because the sign flips. So therefore, if I take away 1 from that, x minus 2 squared minus 1 is less than or equal to minus 1, which definitely means that it's less than 0. If it's less than minus 1, it's less than 0, so it's always negative. The next application is the same thing. It's finding maximum and minimums. So find the minimum value of that expression. So let me just zoom in so you can see what I'm talking about. So to find minimums, I complete the square. So for A, I get x plus 2 squared minus 2 squared plus 11. So x plus 2 squared minus 4 plus 11 gives me plus 7. So therefore, minimum equals 7, because x plus 2 squared is always bigger than or equal to 0, so the whole thing is always bigger than or equal to 7. B, hence, so that means use what we've just done, find the maximum value of the expression 3 over x squared plus 4x plus 11. Now this is the same thing as this, and if I want to try and make a fraction as big as possible, that means I need to divide by the smallest thing possible. Yeah, if you're not sure what I mean by that, imagine I've got two numbers, 2 and I don't know 20, and I want to do 3 divided by a number and get the biggest number. Then I should pick the smallest number, because 3 divided by 2 is 1.5, but 3 divided by 20 is 0.15. So by choosing the smallest number on the bottom, I get the biggest answer on a fraction. So I know what the smallest number on the bottom can be. It's 7. So therefore, the maximum that fraction can be is 3 over 7. Another thing we can do to complete the square is we can use it with our quadratic graphs. We can use it to find coordinates of the turning point, so the maximum and the minimum, and we can find the equation of the line of symmetry. So again, I'll do 2, and you can do 2. So x squared plus 4x minus 3. If I want to complete the square on that, I do x plus 2 squared minus 2 squared minus 3. So y is x plus 2 squared minus 4 minus 3 is minus 7. So my vertex, so I would change the sign of the x, so I get minus 2, and then because it's just a transformation really, because the minimum is normally 0, 0, so I've translated it by 2 to the left, and this minus 7 here I would take to the other side, so it becomes y plus 7, and then I do the opposite for y, so I would get minus 7. So it essentially stays the same. Yeah, the minimum value is minus 7, and it happens when that bracket is 0, so when x is -2. And a line of symmetry, or if I draw the line of symmetry on the graph, it's vertical and it goes through the minimum or maximum point. So that means it's vertical, so it's going to be x equals, and x equals -2. So if I do the one underneath as well, so y equals, complete the squares, I'm going to take the 2 out of the first two terms. Then I'm going to complete the square in the middle bit, so x plus 3 squared minus 3 squared, so -9. I'm going to times that by 2 and then take away 3. So 2 lots of x plus 3 squared minus 18 minus 3. So 2 lots of x plus 3 squared minus 21. So y equals that. So my turning point is, well, I want that bracket to be 0, so x is -3. And if that bracket was 0, the smallest that expression can be is -21. So that 2 at the front hasn't affected my turning point. And the line of symmetry would just be x equals -3. Yeah, you can always sketch this on Desmos or GeoGebra, or put in your calculator and check. If you have a graphical calculator by now, can you try the next to yourself? And again, I'll either give you the answers at the end, or you can I'll send out the answers. I'll probably try and give you the answers at the end. The only hint I'm going to give you is for this bottom one here. It's a negative x squared, so it's going to look like an n, so it's going to be a maximum, but it's still the same idea. You're trying to get the bracket to be 0, and then the minimum or the maximum is just whatever other numbers there. Because this -21, look, I could have took to the side to get y plus 21, so then y is the opposite, y is -21. Okay, so pause and try these two yourself. Okay, another use of completing the square is for finding inverses of functions. So we know to find inverses, I would say, as a recap, I would say y equals f minus 1 of x. So f of y equals x. So I would say y squared minus 4y plus 7 equals x. And if I wanted the inverse of that, I would have to try and rearrange to make y equals. But the issue is I've got a quadratic on the left-hand side. So the way we find inverses or rearrange with quadratics is to complete the square. So y minus 2 squared minus 2 squared, so minus 4 plus 7 is x. So y minus 2 squared minus 4 plus 7 is plus 3 is x. Now I can rearrange it, so take away 3 from both sides. So x minus 3, square root both sides. When I'm talking about functions, I just want the positive square root and add 2 to both sides. So 2 add root x minus 3. Yeah, I only want add because as a function, if I have plus or minus, it'll then become one to many, and we don't want one to many functions. So my inverse is 2 plus root x minus 3. So can you try and do the one next to it? So factorize out the 5, complete the square, and then just rearrange it. So pause it to try that one yourself. Okay, so you should get for that one this working out here. So factorize out the 5, complete the square, expand by the 5, so that's where the minus 20 comes from. Minus 20 minus 2 is minus 22, and then rearrange. So plus 22 divide by 5, square root, minus 2. And then I should have changed that back to f minus 1 of x, which I haven't done yet, so let's quickly do that now. Okay. Another way we can use complete the square is to find the center and radius of circles. So we know that an equation of a circle, if I just write this side, looks like x minus a squared plus y minus b squared equals r squared, where the center is AB and the radius is r. So that means I need to complete the square to find centers, because I want them in square brackets. So for this equation here, what I'm going to do is I'm going to just look at the x's, so x squared plus 4x, and I'm going to complete the square on that. So I get x plus 2 squared minus 2 squared, so minus 4. Then I'm going to look at the y's, so y squared minus 6y, and I'm going to complete the square on that, so y minus 3 squared, take away 3 squared to take away 9, and then I've still got my minus 5 at the end, so minus 5 equals 0. And then I'm just going to simplify it, so x plus 2 squared plus y minus 3 squared. I'm going to take all my numbers to the side, so I've got 4 plus 9 is 13 plus 5 is 18. So my center is minus 2, 3, and my radius is the square root of 18, which I can write as 3 root 2. Yeah, so completing the square helps with circles. So as part of your deal, you can do some consolidation on circles and complete the square. That would be helpful. So look on the textbook, look on the Solomon sheets, look on the Excel textbook. Okay, the next one's still a circle, so we're going to find the center, the radius, and the possible values of k. So center means we're going to complete the square. So if I just look at the x's, I get x squared minus 8x. So if I complete the square, I get x minus 4 squared minus 16. Y is just y squared, so that's already complete the square, so I'm just going to write that as y minus 0 squared. And then plus 9k squared is just plus 9k squared. So then I'm going to have x minus 4 squared plus y minus 0 squared, or I can just leave it as y squared. And then I'm going to put the 16 on the other side, take away 9k squared. So the center is, well, the x coordinate, I need that bracket to be 0, so x is 4, and y, I need that bracket to be 0, so it's 0. For the radius, in terms of k, I need square root 16 minus 9k squared, and I can't simplify that. I can't square root individually. And for c, find the possible values of k. Well, I know that the radius has to be positive, so I know that 16 minus 9k squared has to be bigger than 0. So I need to solve an inequality. So what I do is I would get the critical values. So I would solve it first of all. So 16 minus 9k squared is 0. So I get, if I take 9, add 9 squared to both sides, I get 16 is 9k squared. Divide both sides by 9, so 16 over 9 is k squared. Then square root both sides, I get k is plus or minus, well, square root of 16 is 4, and square root of 9 is 3. So they're my critical values. I will then sketch both sides of my inequality. So 16 minus kx squared, if I sketch that, y-intercept is going to be 16, and it's going to be a negative quadratic, so like that. And I want, when is that bigger than 0? So here's 0. When is my quadratic bigger than 0? It's bigger, this bit here. So between the numbers, the critical values. So between minus 4/3 and 4/3. So k is between minus 4/3 and 4/3. So that's my answer to part C. Okay, next bit of quadratics is factorizing. So you've all got different methods for factorizing numbers. It's GCSE, so I'm not going to recap it too much. I'm just going to show you, if you haven't seen, how you factorize if there's a number in front of x squared. So I get a times c. So a is 6, c is minus 9. A times c is minus 54. So I'm looking for two numbers at times to make minus 54. And my b is 25. So I also want two numbers that add to make that. So try all the different combinations of factors, and I should get 27 minus 2. So you could draw a grid and have 6x squared in one corner, minus 9 in the other, and then separate 25x as 27x minus 2x. And now I can just factorize each column in each row. So 6x squared and minus 2x, I can take out a 2x, and then 2x times 3x gives me 6x squared, and 2x times minus 1 gives me minus 2x. Then 3x times 9 gives me 27x, and just to check, minus 1 times 9 does give me minus 9. So my factor is 2x plus 9, 3x minus 1. Yeah, so that's what's happening mathematically. Or if you want a slightly quick method, once we get to our two numbers, I can put in brackets 6x plus 27, 6x minus 2. But if you notice here, look, I've got one too many 6's, so I need to divide that expression by 6. Now, there's not one bracket I can divide by 6, so I'm going to split 6 up into 3 and 2. So I divide that first bracket by 3, so 2x plus 9, and the second one by 2, so 3x minus 1. Yeah, that's a quicker method, but it hasn't really got the understanding, whereas the grid has got the understanding, but takes a bit longer. The main kind of factorizing you'll do with A level is difference of two squares. So a squared minus b squared is the same thing as a minus b, a plus b. So if you ever see a minus in between two things, be a bit suspicious. Think difference of two squares. So 9x cubed, take away 25x. So there's a minus, so it looks like I can use it. However, x cubed and x aren't square numbers. So the first thing I can do though is I can factorize out an x. So I get x lots of 9x squared minus 25. Then 9x squared and 25, they're square numbers. So I can do difference two squares. I'll have a plus and a minus. Well, to get 9x squared, I'll need a 3x. And to get 25, I need a 5. So there you go. So I fully factorized it. Same for the next one. X to the power 4, that's a square number. And 16 is a square number, so I can have two brackets. I need a plus and a minus. Well, to get 16, I need a 4. To get x to the power 4, I'm going to need an x squared. X squared plus 4 can't be factorized. But x squared minus 4, again, that's another example of difference of two squares. To get a 4, I need a 2. And to get an x squared, I need an x. So I've fully factorized it into 3 factors. x squared plus 4 can't be factorised, and we're going to see later on in the booklet, so after half term, how to find out how many factors, how many roots a quadratic has. So this exam question, feel free to have a go at it, but I'm going to leave it for now, and we'll do it in the first tap on the week back. So that first Monday's tap, we'll go through this. And the last bit is solving quadratic equations. Again, it's from GCSE, so I don't want to spend too long going on it. That's why I'm just doing it quickly. So if you need to practice it, I'll make sure you've got work to practice, but I don't want to waste everyone's time. I know some people will be able to do this. They'll be quite confident of this. So whenever we're solving quadratics, the first thing to check is, does it factorize? So the first one, x squared plus 4x minus 12, that does factorize into x plus 6, x minus 2 equals 0. So the first bracket is just x equals 6, minus 6, and the second bracket is x equals 2. Yeah, I don't want to spend too long on this anyway, because when you get your graphical calculators, they'll solve quadratics for you, and the examiner expects you to use a calculator to solve them. It doesn't. You don't get marks for solving quadratics unless it explicitly says use algebra. For the second one, x squared minus 8x plus 2 doesn't factorize. Now for this one though, since there's no number in front of the x squared and I've got an even number there, then I always find it easiest to complete the square. So x minus 4 squared, take away 4 squared, so take away 16, plus 2 is 0. So x minus 4 squared minus 14 is 0. Add 14 to both sides. Square root both sides. Now I need a plus or minus because I'm getting solutions. And add 4 to both sides. So 4 plus or minus root 14. For C, that doesn't factorize. I can't complete the square. Well, I can, sorry, but I don't want to because I'm going to get lots of fractions. So instead, what I would just do for that one is just use the formula. So A is 3, B is minus 4, C is minus 6, and the formula is x equals minus b plus or minus square root b squared minus 4ac over 2a. So for this question, x equals minus minus 4, so 4, plus or minus square root, well, minus 4 squared is 16, positive 16, take away 4 times 3 times minus 6, all over 2 times a, so 2 times 3. Then just simplify it, so x equals 4 plus or minus square root 4 times 3 is 12, times minus 6 is minus 72, minus minus makes plus, so I get 88 all over 6. Then simplify it, or get your calculator simplified for you. So 4 plus or minus, take 2 out, so 2 root 22 over 6. 2 is a common factor on the top, so I can simplify it by 2. So I get 2 plus or minus 1 lot of root 22 over 3. Yeah, but I don't want to spend, like I said, I don't want to spend too long because your graphical calculator will do it. So for the rest of today's lesson, which you're doing at home, I want you to go over some questions on whatever it is you need to work on. So if you need to work on the completing the square, do the completing the square worksheet, which I'll reference. If you want to do completing the square with circles, I'll reference which worksheet to do for that. If you want to practice factorizing, again, I'll reference which worksheet. And if you want to practice quadratics, then again, I'll reference which one to practice. Okay, so I'll also upload the DIL, and you can get started and become really confident over half term, and I'll see you on that first Monday back. Right, I'll just go back actually and show you the answers to the ones that I got you to do yourself now. Okay, and here's your solutions. So back on the one way, just completing the square. The first one, y minus 2 squared plus 1. For the one after, you can change 4 into 16 over 4. So you get s, take away 7 over 2 squared, take away 65 over 4. For the one after, you would factorize out the 3 from the first two terms to be left with k squared minus 10k. Complete the square to get k minus 5 squared minus 25. Times that by 3, so you get minus 75, and take away the 2 to get minus 77. And the last one, you factorize out the minus from the first two terms, so b squared minus 12b. Complete the square on the bracket, so b minus 6 squared, take away 36. Expand by the minus 1, so that turns into plus 36, and then take away that 7 at the end to get plus 29. And for the ones we have to find the minimum or maximum and their line of symmetry, you can write 1 as 4 over 4. So you half it to get minus 5 over 2, square it to get 25 over 4, and minus 25 over 4 plus 4 over 4 is minus 21 over 4. So the turning point is x would be 5 over 2, and y would stay as a negative 21 over 4. And a line of symmetry is x equals 5 over 2. And for the last one, factorize out the minus, complete the square, times by the minus, and then add the 2 at the end to get plus 18. So the turning point would be 418. And as I said before, that would be a maximum because it's going to look like an n. So the maximum point is 418, and the line of symmetry is x equals 4. So make sure the notes are filled in, and then spend the rest of the time doing the practice.